Good afternoon and welcome to the Technical Libraries. Have I got a story for you? Come on in, we still have a few seats left on the other side there. I want to remind you, I have a couple announcements just before we get started. On your chairs you would have found our little feedback evaluation form. This is a very important tool for us here in the library. We want to know what you like about the program, don't like the program. If you know some other storytellers, because we're always looking for them, or you have your own stories to tell, please let us know that. You can fill them out and leave them with us before you go, or we've put the mail stop information so you can send it back to us later if you get back to your office. You want to do that. And next, I just wanted to brag for just a minute. In June, Sandy Bradley, our former library director, Barbara Lupe, our current library director, and myself traveled to Denver where we presented a paper at the Special Libraries Association convention. Well, that was pretty cool and we thought that was really neat. But then just this month, our paper was published in the Special Libraries Association publication, Information Outlook. So it's all about storytelling, and that's why I'm sharing it with you today. And so we've got some of our posters and what the power of storytelling is in a technical library. And we do have some reprints of the article up here if anybody wants to take that when they go. or we can send you a JPEG file, you know, I mean the PDF too, so. Do you think we should?
And do we get your autograph though?
Yeah. Okay, well, enough about our stories. Well, thank you. Today, though, we have gathered to find out what Mighty Mouse, the Terrier, Sidewinder, and many other things have in common with President Lyndon B. Johnson, and how that all wraps up and where does that all go? Well, Walt Smith is going to tell us. So let me join me in welcoming Walt Smith. Thank you.
Not too long ago, I gave a presentation over here, a simple presentation on technology transfer. And I stepped out of the door, and I was going out the door. This good-looking girl come over to me and put her hand on my shoulder, and that it gets me all excited. You know how that does. And she said, "How would you like to come over and give a full-blown presentation?" And I said, "Well, I guess I could." But I said, "You got to remember, Al Gore, he gets 150 grand every time he gives a presentation." And she looked at me and she says, "What the heck do you want?" Sort of suspicious. And I says, "I want 3 books on arming the fleet." And the reason I wanted these books is I needed one for Bob Hillier, who used to be technical director here. And I need one for my son-in-law, who used to work here and lives in Colorado Springs. And I need one for me so I can look back and see all the history that went on at China Lake. This book was put together by a team here and did one of the most fantastic jobs of listing and identifying every one of the weapon system programs that have been developed here. And believe it or not, there's been close to 50 different weapon systems passed through this center. And you start reading it and you start digging into it, and it is quite amazing. But what makes it real neat is it goes into detail on all the programs that have been generated here, what you can do with them, and it's the best marketing tool you guys can use to selling your new programs with NavAir, the Air Force, or wherever. So it's super critical. You need to get a copy of it. And I asked Ann about it, and she says, "Well, Walt, you can buy them up at the library for 30 bucks. And I said, $90? I'd have to cough out of my pocket? No way. So that's the reason I'm up here. My recommendation to you is get a copy of it and sit and read it and go through it and look at all the programs you've worked with. Now about me. I graduated from the University of Idaho in 1959, and I went to work for NOL Corona on a new technology program. And when I graduated from the University of Idaho, we went through Boise, where all the family is, and then we come down through 395 And at that time, 395 was almost a little bit wider than a single lane highway. And we were driving out through here, and it was 102 in the shade, and it was June 23rd. And we came from Moscow, and that year it was the coldest year we've ever had up there. And as we came down through here, I had a little girl in the back seat. She was almost a year old, and she was crying. And the wife looked out across the desert, and she says, "What in the heck is that out there?" And I said, "Well, that's the Naval Weapons Development and Test Center." And she says, "Well, where do the people live?" And I said, "They live on base, because there's only about 15 or 20 or 30 houses out here out in town at that time. And there's no trees, absolutely bare of trees." And she says, "Who in the hell would want to live out there?" Well, we'll go on with the story. So I went to work at NOL Kuroda, and we worked on a product line of safe arm devices for the guided missile systems: Tartar, Terrier, Sparrow, and Sidewinder. And this little guy right here was being used on Sidewinder. And it's a Mickey Mouse design, as I've always called it. Goes on a 2.75 rocket. They built over, I think it was 50 million of the 2.75 rockets. And it describes about it in here in the book. But it has a G weight on it, and this is the safe arm device that fires it. It was the same safe arm device that was being used on the Sidewinder missile, the Navy version and the Air Force version. And Johnson, I'll get into the other one in a minute. But this thing has a setback weight on it. It has an off-balance rotor in it. It has an explosive lead that without the lead in it. And it arms after missile launch and goes to the arm position, and then a detonator fires the lead fires a booster, and that initiates the warhead. A very simple approach on it. Now, if you rotate it all the way around, then you're going to have to stick your knife in there and unlatch it so they can get it back to the safe position. Then on Tartar, Terrier, and Standard, they had a mechanical design, and it was a big unit, Tartar, Terrier, and Sparrow, excuse me. And it was a big unit, and it was complex, and it was developed back by White Oak in the olden days. A very complex mechanism. And it took up a lot of space. And so we started the work on the design and development of a dual rotor system, and it consists of, this is Sidewinder S.N.A. device. It consists of a dual rotor system, and that had a single rotor in it. And the problem with it is, as a aircraft goes through maneuvers, the lateral load out there will change the arm time on it, and it can arm slow or it can arm fast. And the other problem with it is if you carry it on an aircraft on Sidewinder for 10 to 15 hours, the damn thing will freeze up and it won't function. So we come along with this new technology concept, and it was designed that the guys that patented it had done this about 4 or 5 years before, and they were making a mechanical design almost identical to this. And we took it and made a product improvement program on the mechanical design. It consists of a setback weight that monitors the missile acceleration. It has a solenoid, so when the power comes on the missile, it actuates the solenoid. It sets back, and we have 2 off-balance rotors in it, and we have an explosive lead in the lead rotor. And this rotates around, and it's a true distance integrator. S is equal to 1/2 AT squared. And it rotates around the arm position. When we receive a signal from the proximity fuse to fire it, we have 2 detonators in it, and it comes in and fires the mechanism. There's a couple unique things about it. The circuit board. We needed a circuit board that we could rotate a switch on, and there was none available. And so we come along and designed at that time a circuit board, etched away all the copper except the conductor areas, and then We filled it full of epoxy, flushed it, polished it, and then plated the components on it, and that's the circuit board. And those circuit boards have been used literally by the hundreds on all different type of programs, especially out there in the industry. I would like these back when I get done. Because now I got to watch you guys all the time. I worked out here and I know exactly what's going on. Now I got to look at things. When we were doing the development program, we were at Aerojet General, and we went through a very sequential design phase and technology phase on a program. And I'm going to be putting a view graph up in a second, and we'll discuss that view graph, because this is critical in the design and the development of any product. Now, I don't give a darn what it is. It can be toothpaste. You'll go through these 7 steps in the development. Now, they have given out a program here, kind of like, what is it, Six Sigma program, and I read it, and it's so damn confusing, and it's so almost useless. However, you're going to see this, and you can work from there and take a look at it. When we were working on and developing the safe arm device, in the olden days, we used to lay out the design on a drafting table and sit there and draw up the pictures. And I was working with the team down there at Aerojet General, and back in 1960 through 1962, there was no such thing as a level 3 drawing. And then they come along, and Aerojet had a lot to do to get that enforced and set up a drawing documentation system so that you could take and produce the parts and you could understand it, and it made almost sense. So they did the design and drafting of this new unit, and we went from a mechanical machined out of solid stock to a stamped type unit. We dealt with a guy by the name of Barry Miller, and he did a tremendous job on it. And when we got through with building some parts, one of my jobs was assigned to go out and inspect with an inspector, because I'm not much of an inspector, and write down the dimensions on the drawing of every dimension on that part, on 3 sets of parts. You'll look at a drawing, and about 85 to 90% of the dimensions on a drawing are absolutely, they're open space, almost useless. But what they're there, they have configuration, shape, and etc. But there's about 10% of them that are very critical dimensions, because they interface with the next component that goes together with it. So you got to watch that real close. And we did the tolerance analysis and etc., and we started building parts. And I got the job of running the explosive train tests, and that was fun. And when we started the explosive train test down at Corona, they had a area south of the facility, clear down the back of it, and they had a great big gun turret there. And it had a gate door on it and etc. And this gun turret was about 15 foot in diameter, and the darn thing was about 7 foot tall and weighed a couple thousand pounds, and that's where we did our explosive train test, and it worked pretty neat. We come along and we was doing the explosive train test on that U.S.Navy device, and we looked at it and it says, okay, how close to the arm position will that take and initiate the transfer lead from the detonators? And we did some firing tests, and about 8 to 10 degrees that thing was aligned enough that it would, about 6 degrees from the arm position, it would align enough to go ahead and reliably initiate the transfer lead. Well, the transfer lead, when we were a little bit less than that, about 15 degrees out, it would blow the damn lead halfway in two, and it wouldn't initiate it. And I thought that was neater than heck. And I took a whole handful of these fired up components up to the engineering area, And I sit them on the table and I said, take a look at this. This is just amazing. And the boss come wandering in there and says, what in the hell are you doing? You're not to have explosives out here in the test area, or the engineering area. So I got chewed out on that little subject area. Then we conducted the tests on the boosters. And we started the booster that was the Mark 38 booster, and it had about 150 grams of powder in it, CH6. And we put it in the bunker area, and we initiated it, and it would lift that whole damn turret up about 6-7 inches. Amazing explosion. You got to remember, warheads are designed not to initiate. They can take and fire a bullet into the side of them, and they're not to go bang. You can take and run them into a heavily defended or a hard target device, 1,000 feet per second, and they're not to explode. You can put them in cook-off, and they're not to explode. And we had to take and initiate them. So that's what the boosters were all about. And then we conducted the test on the Tartar and Terrier, which is about 250 grams. And each time that thing would go off, it would just almost. And then, along with it, it would lift the damn turret up about that far off the ground. And I was absolutely amazed with that. And we got all done with the test, and I come back, and I was doing a report and talking to the boss, and all of a sudden we got a phone call. It was from the captain. The captain called us and says, would you get down here? And so we went down, and he says, what in the heck have you guys been doing? And I said, well, we've been conducting explosive train tests on the Tartar, Terrier, Sparrow, and Sidewinder safe arm devices. And he says, where have you been doing that? And I says, out there at the Walt thing. And he looked at me and he says, you know, I have had 3 phone calls from the neighbors out here, and they had big chicken farms outside the area. And he says, every time you set one of those damn things off, the chickens quit laying, and I get these phone calls. He said, well, why don't you take it up to China Lake? And I says, well, I sent up about 15K on another project up there, and those guys run off with my money and used it on some other program, and I had to cough up another 15K. He said, you run your damn test down here, no problem. I'll take the gaff. We did the vibration tests on these units. And we went through a very extensive vibration test and centrifuge test. We went through the transportation vibration test, hours of it. We went through the aircraft carry vibration test. We went through the shock test, 40-foot drop. You name the whole series, and then we'd run functional tests on the centrifuge. And it was sort of a fun game. I had more fun on that darn thing than you ever shake the stick at. This thing was adapted to the Tartar, Terrier, Sparrow, Sidewinder, standard arm, and it was a destruct package on one of the programs. And we just had a lot of fun with it. Then we worked on the walleye fuse program. And it was a completely different operating type system. And it's a fuse about that big around, and it was designed and used to initiate walleye fuse program. And we went through the same 7-step sequence on the thing to design and develop it and test it out and check it out and verify that we had a design that was reliable, safe, and would do what we're supposed to do with it. And we were running a test on it up here, track test. And on that particular unit, it was a little bit difficult for me because we set it up on the track test, and we had the unit so it was almost in the fully armed position. So when we started down the track, we couldn't get into the feed to it to make it armed. And the guys up in the test bay area says, Walt, we have a problem. And I said, what's that? And he says, we're not getting a signal from your fuse. I says, oh. So I went down to the track area and I said, be sure and turn off all the power on the track. Turn off those damn rocket motors that run that thing down there, because they're hard to jump away from. And then make sure the fuse isn't, because it's loaded. And if you impact it too hard, it will go bang. And it's got a booster on it, and it will get me. So they looked at me and they said, okay, it's turned off. And I went down there and I sort of bent over the thing like this as I get into it. And I says, hell, if that thing goes off, it's a microsecond between. I went over and climbed on the back of the warhead, reached down, and I was getting ready to disconnect the fuse from it. And I bumped the cable, and the guys hadn't plugged the cable in. Oh, man. So I plugged it in and went back up there, and they said, we're getting a signal now. She's in the arm condition. We're ready to go. And they run it down the track. These are just some of the little experiences and the fun times I had out here at China Lake and at Corona. And I also worked with setting up Elgin Watch Company to manufacture, Elgin, Illinois, to manufacture the Tartar, Terrier, Sparrow, Sidewinder safe arm devices. And that was a fun program too. And I'd worked with the engineers and the assembly people down at Aerojet, so I had a pretty good background on it. And so I went back there, and Elgin Watch Company got a big contract, and they were manufacturing the warhead safe arm devices. And we set up the centrifuge, and I helped them wire the dang thing up and get it in operation. We set up the electrical test equipment, and I worked with them on that because I had to work with them out here at Corona before. And they set up the assembly line, and things were going pretty good. And they also had a production facility out in Chatsworth. And along came the management of Elgin Watch Company. And that's when, if you build ordnance components, you are evil and it's bad and et cetera and et cetera. And they said, we are getting out of the ordnance business even though it was profitable. And they put both of the plants up for auction. And I got busy with a couple of the guys at Aerojet, buddies of mine. We got drinking. And my honest opinion is don't drink because they'll get you in a lot of trouble. But anyway, we got drinking, and we said, we're going out there and buy that equipment at a real cheap price and set up an ordnance manufacturing facility. And we talked with Barry Miller, who did our stampings and things. And we went out to the auction, and we bought 3 centrifuges. We bought vibration equipment. We bought desks, chairs, tables, test equipment, you name it. We bought the whole thing. Class 1 clean room set up. And we moved it, and I left the Navy and went to work down as manufacturing manager at Barry Miller Ordnance. And that was a fun program also. We started with 3 guys. We had 5, 6, 7 major contracts come through. And we were building the warhead safe arm devices for the Tartar, Terrier, Sparrow, Sidewinder, the whole series of them that time. And also Walleye. And we did the design and development of the HARM safe arm device for the Navy also. I had 154 people working sort of for me, around me, and over me, and under me. And we had a full machine shop. We machined all of our parts. We had Class 1 clean rooms. We had an inspection department. They were turned over responsible to the engineering department. And we had, it was quite an operation. We produced about 30,000 warhead safe arm devices during that period of 5-year period of time. And we also produced a 10,000 walleye fuses. So that was a neat program. And along come Max Electronics, and they liked our operation and how we set it up, and was building a Sidewinder S&A for $99 a piece. And so anyway, they liked the operation, and they come and made an offer to us, and it was fantastic, and it was going to make me rich for life, and I could take up drinking whenever I wanted to then. And then they wanted me to move back to Long Island and work back there. And we worked for them for about a year, but the general manager of that place was not a happy guy. And he said, you cannot be wearing a beard or a mustache when you work for me. And my partner drove a motorcycle. You cannot be driving a motorcycle. And I said, good. And I asked the wife, you want to move to Long Island and live in that environment? And she says, no, that's too far from where the family is. And about that time, they moved those turkeys down there from Corona up here to China Lake. And so I got 2 phone calls, one from Hillier, who was sort of like a brother with me, and one from Hamilton, and I moved up to China Lake. And come over the hill, bringing my kids up there. We lived in Manhattan Beach, and it was nice down there. Okay. And they would go down there and swim, and the wife worked in a bikini shop there and just in a place, and it was just neater than can be. We come over the hill, and they looked down over that valley, and they said, and my daughter started crying, and she said, well, there's there's no beach. And I said, oh yeah, there is 120 miles of it from here down to the ocean. Well, they got along pretty good up here, and the wife started a dress store here in Ridgecrest called Rainey's, and a lot of the women around know and dealt with her. And I went to work, and I worked on, well, I got to look at the list now because I left mine at home. I worked on a harpoon fuse program, and there's 2 guys working on it, neater than sharper than heck. But before I go on that, let's put the sign thing up there. Okay. There is a 7-step program that goes through the design and development of anything. And it's a research phase. Let's go back to the previous one. Can you make it go backwards? There it is, the research phase. This center has done more programs on the research phase and research technology than any place in the world. It is amazing all the different configurations and things that have come up, and they come through and say, oh, they had a tremendous number of doctors here. They had tremendous number in math and physics and stuff, and same with the science and et cetera, and engineers. And these guys come up with concepts that was just fantastic. And this phase is the same phase you'll walk with when you build anything. I don't care if you're building a car or building a bicycle or building a fuse, you're going to walk through this 7-step function. And they come along with the research phase and they say, hey, we got a pretty good idea here that will work. Then you go to the next phase, phase 2, an exploratory development phase. And that's where you'll usually come up and pretty well come along with your concept and then proceed to get a patent on it. Now it looks like it's a patentable product. And this center has more darn patents out there on different products than any place I've ever seen. Then you go into the next phase, and that's the advanced development and contractor support phase. And when I came on board on the harpoon fuse, these guys had sit there and they had made drawings and they'd done a pretty good design on the harpoon fuse, but they hadn't started building any parts. So I said, we got to get some assemblies together to make sure that they'll go together, see what they look like, and build them. And so I went out to Aerosmith with drawings, and I'd go by the next day, pick up some parts, and we put together the first harpoon fuse in about less than 30 days. And they had a model there in front of them. And it didn't work too well. So we went through and made modifications to the drawings. And these guys did their drawings on the drafting table, like 90% of the drawings in the old days was done. Then we come along with the advanced development phase. Okay, you got it, there you go. And you're going at this phase of the program with contractor support. And you're going to put up a bid package. You're going to prepare a bid package, and you've got to design pretty well like what you want and need. And now we need to get it manufactured and produced. Next step. The engineering phase. And this is where things get a little on the tough side. You can squeeze through the first 3 phases through money you can steal, beg, borrow, and from other individuals around the place. But when you get into this phase, now you're going to have to cough up with some money. And back in the 60s, that wasn't a major problem. Because what was going on at that time frame is we were preparing for battle with Russia. And so the funding on developing any weapon systems to take and work and function and etc. was relatively easy to get the funding on. And then on top of that, we had about 8 or 9 programs going here at China Lake. And with those 8 or 9 programs, those 8 or 9 guys were back there in Washington marketing and getting funds and going through the budget cycle and getting funds to take and support the activity. Those guys retired. You don't have them anymore. And the center needs to start pushing that philosophy and program. And then we go into the prototype phase after you get the funding. And this is where you're working with the contractor to build a quantity of units. And they're going to go through the drawings and verify them. You're going to go through the design and modify the design that you've come up with, and then you're going to go through the testing. And that's a fun type sequence and program, especially for an engineer. Once you go through the testing program, and I'm talking vibration and track and flight and etc. with the weapon systems. On Sidewinder, we had to launch 2 inert Sidewinder safe arm devices before we could fly a live one. And this is from a safety point of view, and they TM the packet and etc. And this is the way to do with most of the ordnance products that are used out on the ranges. And we go through the same test program on this one. Then you're going into the pilot production and release to production. And on the bomb fuse program, there's a guy back there by the name of Bartles and James. And he wrote up the full-blown production release on the bomb fuse program. And what was neat about it is he had this 7-step program. I didn't ever see it. I had never seen it when I was going to college. I never saw it when I was at Corona, never saw it when I was here at China Lake, but it is the same 7-step program. And then you get it released and you go on to unlimited production, and that's the fun part of it. One of the important things about the 7-step program, and you guys need to get it laid out and look at it, it is every step down the line, and you have to go out and do the marketing on it. Now, I told you about Berrymill Ordnance and how we bought the equipment, set it up, and the walleye fuse. Then we sold Berry, and then I moved to China Lake, and then I worked on Harpoon, Condor, Tomahawk, Phoenix program. Phoenix was another neat one. And the Phoenix weapon system was used on the F-14 aircraft. They could take and launch 4 Phoenix missiles at one time against 4 different aircraft out in the sky, and they'd track them and knock them down. And what they were worried about is if our friends across the ocean were to attack us with a batch of aircraft, they could take them out of the sky, and that was the Phoenix program. On the Phoenix program, it had a rocket motor armed fire device built right in with the fuse, and it also had a warhead initiation system as part of the fuse programs. And it was a pretty complex system. And then we did the RAM program and FAY. And now I got to tell you about the FAY program. The FAY program, Larry Brower handled the FAY program and was doing a pretty good job on it. I had to give him a lot of direction though. But anyway, doing a pretty good job on it. And on the FAY program, I was talking there with old Jim Bowen, and I says, Jim, that FAY program, all it does is go whoop. There's no blast frag. There's no metal particles coming out of it. There's no shock. It just whoop. I says, it's nothing. And he looked at me and he says, well, Walt, he says, we're getting ready to run a Fay test out there at Salt Wells on a tower. And that's when they were developing the bigger Fay weapon. And he says, we're going to open it up, expand the thing, and then we're going to drop the 2 parachutes into it with a firing charge and make it go vroom. Would you like to watch the test? And I said, sure, I'll come out there with you, Jim. And next morning we went out there, and well, we was quite a ways from it. And I noticed Jim Bowen standing like this looking at it. And me, I was standing my normal way, bent over looking at the damn thing, and he says, here it goes, and you can see it opening up and the clouds to start to form. Parachutes dropped into it, and it went vroom. Well, that shock wave come sailing down that area, hit me in the chest, it knocked me flat, and it upset my stomach something terrible. And I looked at Bowen and I says, Jim, you got us a little close, didn't you? He says, no. He says, didn't bother me at all. He says, I'm standing this way. But it was amazing. Then he said, well, what do you think of it now? And I says, well, I have a different attitude on the Fay program. And that Fay program was used heavily over in Vietnam because the guys that get in the tunnels, they'd come in there and drop the Fay weapon in there, and it would, shock wave would run up that damn tunnel, and it caused headaches and emotionalism. Oh, then I had a buddy, Lauren Russikoff, worked down there at Corona with me, and then he moved up to China Lake when they moved up here. And his wife didn't like China Lake, so they moved to Point Mugu, and he became a manufacturing manager type thing down there on all the bomb fuses. And he and I would talk quite a bit, and old Lauren gave me a call one day and he says, damn it, Smith, we need a new bomb fuse. What can you do about it? And I says, well, let's talk. He says, I got those guys at White Oak, and they have they work on this bomb fuse, and the dang thing is about 65 to 70% reliable. A pilot will take it out and attack a heavily defended target. He launches his bomb, and the damn thing doesn't go off, and he got to come back and take a repeat trip on that thing. And he says, we need a fuse that's reliable and will work. So I says, okay. So I got a couple of guys, and we were talking with them with regards to exploratory development of electronic type fusing system. And we had a major program going on to do the bomb fuse, and I went back to NavAir and went back to NavAir also, and we proceeded to sell the program and saying, yeah, we do need a new bomb fuse, and we sold the program. And then we went to the Air Force, and then there was a big gun battle that went on. And what happened is the Air Force come along and said, we will drop 1,000 warheads, and you guys in the Navy will drop 10. Therefore, we should have technical lead. Well, we had started the design and development of an electronic bomb fuse, phase number 2 and phase number 3, here at China Lake. And Higuera and I both were involved with talking to them. We even had a congressional meeting on it. And we got pretty heated on that subject area. And the thing that sold it was basically the information that listed in this Army and the Fleet. We sold them on how we had done the design and development of the Tartar, Terrier, Sparrow, Sidewinder, Strike Harm, SNAs, and on top of that, they were cheap and reliable and safe. And the reliability was a critical factor, and I'll be damned if we didn't get awarded the technical direction of the program. And when we got that started, now we got funds. And we set up about 7 guys in that little group with us. And we had a guy by the name of Larry Brower. We had that guy sitting there right behind you. He was there involved in the group. We had another guy, we had 2 electronic guys just sharper than can be. And then we had Ron Cohen. Now Ron Cohen is a hard-nosed, miserable SOB to deal with. Oh, he is. But he knew the testing program better than anybody I've ever seen in my life. And when you're developing a bomb fuse, you got to drop a bundle of them. And Larry Brower had a little computer, a Mac computer like that, from home. And he was doing the plans and laying out the different tests we had to go through, and it was just phenomenal. And it worked great. And Cohen would come along and say, oh, we need to clear through the track area, and we need these safety requirements, and we got to pass this, and then we got to go through the flight test program, and we got to go through all this. We got to get the range approved it. We got to get the aircraft to fly it, and the whole bit. And it was sort of a complex situation. Ron did an amazing job on it. And we started the development program with Motorola and proceeded to design and develop a new bomb fuse for the general purpose bombs. And there's about 9 bombs the Navy uses, and I think the Air Force has 11 or 12 of them. But anyway, we went through the design and development of the FMU 139 bomb fuse, and that's what the guy looks like. And if I had a cutaway section, it would amaze you because it's 98% electronic. And the amazing thing about it, it works. We ran tests on it, and the reliability of that program was running in the 95 and 97 category. And if I had another book that I left in my office, I could show you some of the data on it, and the 7-step program and the whole bit in there, and all the steps we went through. We started the design and development of it. We did a whole bundle of tests on it, and then there was an old proximity fuse that the Navy had and the Air Force had. And the problem with that prox fuse is the two of them would be flying together, they'd cross-talk, and when they cross-talk, they'd initiate the warhead before it got to the target. And so we went into a dud mode on that prox fuse, so that if the prox fuses were talking to each other during the arming sequence, then we could take and put them into a dud mode and go on impact, and it worked out very well for us. The bomb fuse program was an amazing program here. We did it in about 4-year period of time, and we got it released to full production. And part of that program was the tooling on it. What happened is, I went back with a guy from Motorola on one of my many vacations to Washington, and I had a long talk with him back there about tooling. And the guys from NavAir says, oh, we don't have any funds for tooling. I went over to the Air Force. I says, damn it, we need to get the tooling funds in here for the bomb fuse program. We don't fund tooling programs. The contractor does that. I said, boulder dash. I've been on about 7 different programs, and the funding has been provided for tooling and test equipment and stuff like that. And they said, well, go to Picatinny. They've been funding tooling type programs. So I got with Motorola, and I said, okay, lay us out a couple programs. One for about $2 million, and that puts us pretty good tooling. And then one above $12 million. And they put together a $14 million program that was horrendous. And so we went to Picatinny, and I got in there and was talking with the guy about it. And he says, well, Walt, how much you need? And I says, well, we can set it up on a double type program, one for about $2 million and the other about $14 million. He says, I can't fund the $2 million program. I says, why is that? Not enough money. I mean, I couldn't believe it when that come across. And then he looked at me and he says, tell me about the $14 million program. That's when Motorola pulled out the whole package on it, what we were going to do. We set up that bomb fuse line like you could not believe. The most modern assembly line in the whole world. It was fantastic. We would make the circuit board assemblies, and we would take it and run it through, and we'd had equipment to install all the components, electronic components on it, and there's probably 30 or 40 electronic components. It would go through the soldering operation. It came out of that, still on this line. Come out of that operation, and then they would take and do all the electrical tests on all the circuitry, and then they go in and they go around, and then they'd assemble, put the thing together, assemble it, and run it through the final test, and you had a good fuse. And we ran all vibration tests, and we ran all the track tests, and we conducted about 250 track flight tests out here at China Lake, and 9 different track tests on that thing, and we accomplished all that in a 3.5 to 4 year period of time, which was quite amazing. And the guys out there, the Air Force was out there. Oh hell, we was out there running the first series of tests, and I was standing up there on the top of the tower with a Navy captain, and the Navy captain from here at China Lake was up there with us to watch this new development program, and there was a colonel from the Air Force was there, and a couple of the engineers were there, and we was all standing up there watching it. And my good friend Ron Cohen come up, and he says, "You guys get the hell off of up there. We can't conduct the flight test until you clear the table." I says, my test engineer is a little bit on the testy side, guys, so we're going down to watch the whole program. And they say, they understand it. They want to get the flight tests off. So anyway, that was Ron Cohen. He's a neat guy. I still like him, and we get along pretty good. Now we got proximity fuse program. Then they come along and said, there was a gal by the name of Dr. Peggy Rogers. A neat gal, and I called her Aunt Peggy. And she come along and she did the analysis and the study of a warhead. If you initiated above the ground, it'd improve the output by over 30% to 35%. And what happens is the warhead will blast down and out, and if it's in the ground, it just blasts out. So she did this analysis, and she talked to me about it, and she says, we need to develop a proximity fuse for a general purpose bomb. And I was going vacationing in Washington every week, or every other week, so I went in and I talked to them on the program. And we got into some pretty heavy, heated discussions on that phase of the program. They go, we don't need a prox fuse. And then I went to the Air Force. We don't need a prox fuse. And then I went to all the different other programs back there at NavAir. And this was the best one. And we'll pass this around. This is Jim Bowen. And he was back there on his year vacation in Washington, and he was on the Gator program. And I went back there, or Big Eye program, excuse me. He was back there on the Big Eye program, and I'd cut this thing out of some magazine showing all these over a couple $1 million worth of money sitting there. And I went down to TID and I said, we got to put Bowen's picture up there, and I got to take it back to him and hustle him a little bit. And it says, damn it, Bowen, all I want is a measly $500K to get moving on my prox fuse development program. It worked. Believe it or not, it worked. But that's not what made it work at that particular time. He did go around and talk to all the different people around the area about the need for a proximity fuse, and he was doing the hustling for me. And it was sort of a fun, it's a different approach on marketing, but it worked. What was happening at the time is we had a new program here at China Lake, and it was a top secret program. I don't think I can talk about it, but I will. Anyway, they had a battleship, the Russians had a battleship called the Kiev. And if they were to take and fire a Harpoon missile against the Kiev, they would knock it out of the sky before it got there. And they come along and says, now if we would come along with an aircraft from each side and each end and loft these rocket eye bomblets onto that ship, come into a loft maneuver and then get the heck back out of the area and fly right along the water edge, they wouldn't knock us down, we would disrupt their fire control system, and we could take that ship out. And then we could shoot the harpoon against it, and it would work. Well, the neighbor guy was one of the pilots on that particular program, and he says, we have this new program going on. And he says, it's secret. And I said, well, heck, I had the Unholy Dickie's secret clearance level, whatever it was at that time. And he says, I know, I already checked you out. But anyway, we talked about it. And what they did out here at China Lake on Inyo-Kern Road, and you'll notice that there's 2 towers stuck way up in the air over the power poles. And at one time, there's a string of flags across those towers. And then the land mass on the other side of Jack Ranch Road was set aside for flights coming in, and the Navy has control of it, so that they could fly at ground level, up and over the top of those power poles, then back out, go in their loft maneuver, and then come back out. And they had quite a test program on it, and it made a hell of a noise around here, and people was wondering what was going on. Well, that's what was going on out there. And it was nobody would talk about it. But the amazing thing is when they would do the loft, they had to look at the angle that they lofted. They had to look at the velocity they lofted. They had to look at the distance that thing traveled so it would land pretty close to a ship. And then they took, there was a ship over at Point Magoo, a target ship, that we'd punched a bunch of holes in with harpoon. And anyway, they took and they did a loft maneuver against that. He did. And he had a couple pilots with him, and they went after it with the Rockeye bomblet. And they went over the first day, and he came back, and he was sort of sad. And then they took another trip at it, and he was sort of sad. And we had started the design and development of a proximity fuse, and we had 2 prox fuse guys that were brilliant at that time, and still are. One of them died, though, right in the middle of the program. But anyway, we started the design and development of a prox fuse program, and we went through the 7-step function on it. And I brought back in proximity fuses from that the Navy had and the Air Force had, and they looked at it, and they took them, and they looked at it, and they said, oh, this is what's wrong with this is what's wrong. And they made major design modifications, and they built up about 3 of them. And this pilot come back, and he said, we need a proximity fuse. And I says, well, we got a proximity fuse program. He says, I know, you've been hustling us back there on for it. And he said, do you wouldn't happen to have a couple of them? And I says, well, there's a couple of them out there that the guys have put together. I don't know how good they are. They haven't been through all the testing, and they haven't been through, etc. He says, can I have them? And so he took one, put on an aircraft. He went over to Point Magoo, did the loft maneuver. It splattered that deck covered with Rockeye bomblets. And he come back, and he was smiling, and he ran another test. Same thing occurred. He says, Walt, tomorrow morning there's going to be a captain from NavAir out here, and they're going to be talking to you about funding of the proximity fuse program. And that was out Salt Wells, and I said, come bring him out. And I went through with him all the different safe arm devices and how brilliant we were and how wonderful we were and what we'd accomplished. And then come along down the pike, and he says, when are you going to make delivery? I says, sir, I need money. Well, how much money do you need? He was a hard-nosed captain. He says, how much money do you need? And I says, it'll be about close to $3.5 million. He says, I'll have the money here on Tuesday next week. It moved that fast, but we had been marketing on that program for over a year and a half, and finally got the funding shaken loose because they needed that product now. And right in the middle of that program we had a president of the United States come along, and it was Reagan. And he come along, and he had an agreement with those guys over in Russia that we're not going to kill each other today. And all the programs pretty well backed off at that stage of the program. How's my time doing? Oh, Christ, I'm going to be overtime. Then I left in 1984 and I went to work for Micronics. And I became part owner of Micronics. And at Micronics, they had picked up a lot of the tooling from Elgin Watch Company, and they had the centrifuges, they had the whole capability, and they were doing safe arm devices for the Sidewinder, Sparrow, Standard Arm, Phoenix, Mick-Lick, and I'm going to talk about it because it's neat. And then they developed the AMRAAM S&A device for the Air Force, and then we produced 1.2 million flare cartridges. And the flare cartridges are used to kick out a flare or chaff or aircraft that's being shot at, and you hope the missile will chase the flare. We also built 2 cable cutters, one for the Navy. Now what happens is on board a carrier, they bring in literally tons of supplies weekly and daily. And they have a cable running from the supply ship over to the carrier. In fact, they have 3 or 4 of them, and they're bringing this stuff, supplies in on the lower deck, and if they get into a hostile environment, they need to get out relatively fast. And so they practice on that, and they try to unhook the cables and get them shifted over. And if they don't get them unhooked, they put this cutter on it, and it cuts the cable, and then they can get on with their work. Then we designed and developed, and that same technology was used for the Navy SEALs, and their approach was they would dive down under a ship, hook these cutters on the anchor lines, set them off and get the heck out of the area and have them set off over a time period, and then these ships were cut loose, and if the wind was blowing, they run them into the shore, and it caused them a lot of emotionalism. So that was another program we worked on. And then the third one was the cutter for the helicopters. And it was, they would drop a load down on a carrier or ship of usually mail and stuff like that, but is important. And they'd drop it down, and they'd reach out with this, and if it got hooked or tangled, they'd reach out with this little cutter and cut the line, and then they could get away. Now that was also a neat program. But Mick-Lick, I got to tell you about it. Mick-Lick was a program done here at China Lake for the Army, and it's called a mine clearing charge. And what would happen is on the Mick-Lick program, they would take and launch this thing over about 30 or 40 bags of powder over a minefield with a Sidewinder, modified Sidewinder motor, and it would land down there, and they'd initiate it, and it was used heavily in Desert Storm. There's a couple areas I meant to tell you about the bomb fuse, so I got to go back. I'm running over time, lady. She took a half hour to, that gal took a half hour to get it started, so it's okay. Anyway, bombs. We built at 990,000 bomb fuses for the Navy and Air Force. And they're almost out of them now. And they're looking to set up again and build some more. But the important thing about it is how they were used. And in Afghanistan, the Russians went after those guys up in their caves and up in those barriers and places that they had for about 5 years and didn't do too well with it. And the way that, not too many people are aware of this, but the way the program was handled by the Air Force and the Army is they would fly over there at 10 o'clock at night with a B-52 and string out 80 of those Mark 82 bombs. And they'd cover a territory about the size of Ridgecrest or a little bit longer, probably 10 to 12 miles. And if you dropped them in Ridgecrest, it would destroy the whole town. And these things would go off, and they'd tear up their defensive systems and raise heck with the tunnels and etc. 2 o'clock in the morning, they made another trip over it. And then all day long, they'd fire artillery shells at it. And then after about 2 days of that, they'd run the troops up into that section and clean it out. And these guys hadn't gotten any sleep for 2 or 3 days. They did that, and they walked all the way through in Afghanistan. Desert Storm the Air Force dropped 240,000 bomb fuses. That was my records. Army and the Fleet says 200,000. So I'll go with him. Then the Navy dropped 9,000. The only difference is they were dropping the Mark 82 weapons, and we were going after pretty heavy defensive systems and targets with the Navy and the different bombs and warheads we use there. And then we went through a whole batch more of those bomb fuses when we played the game the second time. And so it's amazing the number of fuses that was utilized in those particular programs. The other thing that went on is they also used the proximity fuses up that the Navy had, the older ones, that didn't work as well as they should. And they used up all the old mechanical fuses because they put one on the front of it, an electronic bomb fuse on the aft end of it, and it worked extremely well. They got rid of all that old inventory that was almost worthless. And it was paid for on Desert Storm by the other countries. Our troops were over there, and all of our battles were over there, and it was paid for. The second one, well, it's a little bit different that way. We're paying for it now. There was another program that came along, and there's a guy there, Jim Johnson, was working on that particular program, and it was a Sidewinder safe arm device for the Air Force program. And we had been up to Hill Air Force Base 2 or 3 times talking with them and telling them they need a new safe arm device because they would take that existing missile, shake it on an aircraft, and in about 15 hours of flight time, the damn thing would freeze up. They'd pull the thing out and send it to N-80 Crane, and they'd run tests on it. And we went up there and we talked to them, and we hustled through a buddy of ours up there about it, and not too much results. And then Jim and I went up there to a meeting they had, and they had all the NATO countries there. And there was about 6 or 7 of them: Germany, Denmark, Norway, Sweden, and old Jim got to sit down on the front line, and I had to sit back up in the balcony because he said it was ugly. But anyway, I got to sit up back on the balcony, and they went through the whole program, and the Germans were happy, and the Swedes were happy, and the Denmarks were happy. And then it says, any other comments? Nobody said anything, so finally I opened up my big mouth, as I usually do, and said, if you carry the Sidewinder missile with the existing safe arm device in it, it will freeze up and will not function. And you have never heard the conversation go on thereafter. The Germans were speaking German. The Swedes were, and I mean, it was really one heck of a mess, and I had to chuckle with the whole damn thing. Then there was a meeting called, and I got volunteered to go up and meet a general, Air Force type, and the colonel was there with us, and the discussion got pretty heated, not from my point of view. I said, you got a missile system that doesn't work, and Crane runs a test on it, and we brought this out at the meeting, that Crane tests them, and they're not reliable. Well, Jansen ended up getting funded a 3-man year of support, and are you still on it?
The money ran out.
And we're doing it for the Air Force. Well, about that time, a technical director came out to the laboratory out there where I was, and he walks in and he says, well, he says, what in the hell are you doing on Sidewinder for the Air Force? And I says, well, we want to make the safe arm device for it and make sure the damn thing works. He says, you know, that interferes with the Navy program. I said, no, it doesn't. He says, well, it interferes in another way. And I says, Hayes and I got along pretty good. And I says, Hayes, I have a question. If we go to war, is the Air Force on our side along with the Navy? And are they going to need missiles to shoot down those targets that are coming at us? And he says, go ahead and have your damn program. So that was an interesting situation that went along. Okay. I sold my chronics and then I went to work for a company called High Shear Technology. And High Shear Technology was working heavily with regards to laser firing systems. And they were also working on another system that was quite unique. And they did the shuttle program. And they had 132 cartridge actuated systems on every flight. And while I was down there working with them, I got to work on the separation bolts. And there's 3 of them that hooked the shuttle to the thing. Hit those separation bolts from each side and split them right in the middle, and that opens it up and they fly. And each time they have a shuttle flight, I've got to watch. The launch doesn't bother me at all. That's when they go through the separation section and the next steps down the line, it makes the hair sort of stand out, and I got to work on that program. That's sort of fun. Well, I was up here working with them to market the little laser firing system. And the lasers at that time were not too energetic. And we had done a lot of work out at Salt Wells while I was out there with regards to the idea of putting a laser to, when you kick a weapon away from the aircraft, you fire the thing with a laser firing device, and laser initiation systems for rocket motor armed fire devices, and etc. And I had a little laser, and it's about the size of my thumb. And it was a neat little guy. And it had a fiber optics coming out, and I had about 40 foot of line on it. And I put, on the end of it, I put ZPPs, or cadmium potassium perchlorate, something like that. And it would go bang every time. It was neat. And I had 2 or 3 guys from Salt Wells who used to come down to my office down there, and we'd play tests with different explosives on that thing. See how Rex Smith was one, and then Phil Ankeny was the other. And they'd come down, and we'd do some testing on it and playing with it, because they couldn't get it done out there at Salt Wells, so we did it down there. And that was really a neat program. Then they had lunch racks, the ejection seats for aircraft, and High Shear built all the cartridges and all the rocket motors and stuff for the ejection seats on the Air Force programs. And they were conducting a special program out here at China Lake, and so they had moved me back up here to China Lake to stay up here. And it was sort of a neat program. And we got to run about 4 different sets of tests out here in the ranges. Again, it was just a lot of fun, especially when you watch those things eject from an aircraft and the G-forces those guys receive when that happens, and etc. So that was sort of a neat phase of the program. And about that time, we come to what is known as Technology Reinvestment Program. And so if you take a look at the technology, he's raking me already. No. Technology Reinvestment Program, let me go into a little bit on that. Not yet, after this. She's the one that whacked me, not you. Ma'am, sir. Anyway, on the Technology Reinvestment Program, we worked on a program out there at Salt Wells on a little computer chip about the size of your thumb. And what it does is it was an impact sensor. So when you hit a hard target, it would close and then fire the warhead or the fuse. And Jim McVeigh set it up, did a tremendous job on it. Got an SBIR program going on it. And on that little program, we went through a whole series of development tests. And then we went through the first batch, and it worked pretty good, but it was sensitive. And then we modified the design slightly, or McVeigh did, and got it working good. Then we went through the third step, and it was fantastic. You could vibrate the heck out of it, you could shock it, and it would operate just like it's supposed to. That little chip in Technology Transfer Program will save your life, or your life, or your life, because it's used in the airbag program. and it's a little chip that goes into there. And that guy up in Seattle is now a multimillionaire, smiling and building chips for the airbag industry. The second technology program that talked about in this thing is the one down at High Shear Technology. And at High Shear Technology, they came along, and I was living up here at the time, and they come along and President Clinton's organization come up with, why don't we take this technology we designed and developed in the aerospace industry and convert it into a commercial product? And so one of my buddies was down there, and he drove up here and he says, Walt, we want to put in a proposal on this technology reinvestment program to take and rescue people out of automobiles. And I'll cut the 4 posts off. And I says, okay. And he says, then we got to put together a proposal for it. And I says, well, what the heck do you want me to do? And he says, well, you got to design it and build it, because you used to build cutters for the cut cables on chips and stuff like that. I says, okay. And so I went out in my garage and I built a unit. It's sort of crude. I took it down to High Shear, and I did all the calculations of how much energy it needed, the whole bit, to cut through a post on a car. And I was a little off quite a bit, but anyway, we took it down and we got some sample posts to cut off of cars, and bam, it worked. Then we went through the 7-step program. But before we did that, I submitted the proposal to the old man, and Tom Mooney looked at it and he says, the damn thing won't get funded, but go ahead and submit it. 2 weeks later, after I'd submitted that proposal, I get the phone call from Washington. And the guy there says, Walt, your technology proposal to build rescue equipment for the fire departments, we want. And you're number 1 on the list. I've been on a lot of number 1 lists. Anyway, we want it. And so we went through, and he says there's going to be a meeting with President Clinton next week, and we'd like to have you or somebody from High Shear back here for that meeting. So Clinton, or the boss, he said, I'm going back. He's a good Republican, and I don't know how in the hell he got along with Clinton on that subject area. But anyway, he went back, and Clinton got up front and he said, this is our number 1 choice. These guys have come up with taking space age technology where it's being used with the military and etc., and converting it over to commercial product, and we can rescue people out of automobiles. And he said, when I was governor, wherever he's governor of, he said, when I was governor, we bought a set of rescue equipment for 1 fire department. It cost $16,000. He said, I had 22 other fire departments I needed them for, and I couldn't afford it. And you guys can build this thing for about $3,000 for a set, and and they're easy to operate, and they're fast, and they don't have all the hydraulic stuff, and don't take up much space, and go for it. And we come back, we set up a separate division down there. And we got it going, we got it organized, and it was going great. And we come up with new designs. We went through all 7 steps, let me tell you, and got it so we could take and cut. And we went through probably 200 cars demoing them. And in fact, I got involved with the fire department on a rescue mission one time, and I was out there and saw exactly what they went through. And what happens is, if you get a head-on impact, the engine compartment comes back in and it pushes the brake pedals down over your legs, and then they can't get your butt out of there. And so they had a little tool. We go in there and pop that thing, and it rescued this person. So it was sort of a neat program. But that's not what sold the program. They had a program called Oklahoma Disaster, where they blew the whole side out of that big tall building back there. And I heard about it, and I went down to the fire department guys and I said, could you guys go back to that program? And they says, yeah. And they flew in that night, got back there, and checked in, and the next morning they gave me a call and they says, Walt, we need those damn cutters back here. And I says, why is that? You got the hydraulic tools? He says, yeah. but it's got a 1,000-pound motor on it. It's got a line that's only 15 feet long, and we have to get back in there and climb over all this rubble to try to rescue these 3 people that are still alive. We need your tool. And I says, I'll be there tomorrow morning. So I gets in the airplane, I went back there, I checked in with management down about 2.5 miles from the disaster site, and told them what I was there for, and if they'd call the fire department, I'd go down there and meet them at the disaster site and they'd pick up the tools. And so they said, go ahead, Walt, we'll call them. So I drove down there and I got out of the car and I just turned around and here pulled this policeman. And I don't know whether it was a sheriff, a policeman, or what the hell ever he was, but he jumps out of his car. He pulled his pistol out of his damn belt and aimed it right at my head. And I looked at him and he was shaking. He said, what the hell are you doing here? I'm here to deliver some tools to the fire department. And would you point that pistol off a little bit? Because if you hit me in the brains, I don't have very many anyway, and I don't want them, all the rest of them blown out. And about that time, we opened the trunk, and he looked at the tools, and about that time, the fire department come up there and pick up the tools. And they went in there, and they took the little cutter, and they was cutting rebar. And they just, shit was all over the place. And they were cutting rebars and they rescued the 3 guys out, and it was covered on television. And then the big one is there was they call it a widowmaker, and what it is, a big chunk of concrete, about 2,000 to 3,000 pounds of concrete hanging off the top of that roof with a chunk of rebar on it. They reached out with that little cutter, full coverage on TV, whacked it, it dropped down, and sales went crazy. We started selling the tools to South America, Australia, New Zealand, Europe, even Canada. And it was amazing. And the old man comes walking in and he looks at me and he says, well, Smith, he says, you've done a hell of a good job for us, but we don't need you anymore. I got fired. I says, are you firing me? He says, no, I'm not firing you. We're just not going to have you around here anymore. And I says, good, God. This is what the big LifeSure cutter looks like. And they're still producing some of them. Then, I'm still going. Then the second technology program, a third one, and that is a Catco's cartridge actuated cable cutters. And this is what it looks like. And I come home, and we lived down in Palos Verdes at the time. I came home, and I had a little bit of money at that time. And I said to the sweet, lovely wife, I says, where would you like to live? She says, I want to move back to Ridgecrest. I says, holy shit, no. She says, yeah, I want to move back to Ridgecrest. And I says, why is that? She says, I know half the people in town. They're friendly, they're a neat bunch of people, and you had me stuck here in Palos Verdes, sitting right next to where all the Japanese had their homes around there, and they would come in and they'd be there about 6 or 7 months, and they'd send in a new batch. Didn't know anybody. Go down to the stores, they're doing battle in the stores. It was amazing to her. And she says, I want to go to Ridgecrest. There's no people there. Well, there's a few. And she says, the people are there and there's no traffic, nothing, she said. So we moved to Ridgecrest. And we got up here and I said, well, hon, I'm employed. I'm not working anymore. I've owned and operated 2 ordnance houses. I know how bookkeeping and all that. And we'd been married about 40 years at the time. And she looked at me and she says, what you're telling me is you want to, I've been handling the books for 40 years, and you want to get your nose in the middle of that? I said, well, that was my suggestion. She says, you're that close to death. She says, you're so damn smart. Why don't you take that technology and design and developed in the aerospace industry and convert it over to a commercial product? And so I got involved with a gentleman by the name of Jim McVeigh and Ed Cooksey, and we went through, and I had designed and built, step number 1 and 2, the first cutters. And my firing mechanisms were a little bit crude, but the cutter worked pretty good. And then I got Cooksey on board, and Cooksey used to work at Picatinny Arsenal in gun mechanisms, and he's also a gun nut. And so he come along and did the basic design of the firing mechanism and the gun mechanism. And we have a total of 9 different tools that we're selling to the power line industry. Now we're located out on Inyokern Road, and we're having fun with it. And I'm staying out of the house. The wife is still speaking to me 11 years later, 51 years of marriage. It's happy and wonderful. But anyway, we go on with the thing, and we started designing, developing, testing these things, and we went through the 7-step program with it. We started selling them to Southern California Edison, and before that, I looked at it and I says, what kind of business is the power business? And I started analyzing it, and I got a book, and it's about that thick, and it's a pretty good sized book, and it lists every power company in the United States. There are over 500 power companies in the United States. It lists their income. Their income yearly in the United States is more money than is spent with the Army, Navy, Air Force, and Marine Corps. That's the reason your power company bills are so damned high. However, while we're building ships, you guys are building ships and airplanes like that, they're building power plants. And those power plants are sort of expensive. Along with that, then I looked at it and I says, what's the manpower? They have more men working in the power industry in the United States than we have in the Army, Navy, Air Force, and Marine Corps, even under today's program. It is big business. And I said, man, that's the business I want to get into. And I left my cartridges at home, and I was getting ready to sell about 4 or 5 tools to you guys, and I can't demo it today. But we designed the little cutter, and it's the A1. And they have a thing called a crossarm bolt, and it looks like that. And they bolt the crossarm to the pole. And OSHA has come along and says, you got to cut that damn thing off within 1/8 or 1/4 of an inch or 1/2 inch of the nut. And this little cutter does a neat job on it. And I was going to demo it. I did it last time though, and it worked. And but anyway, then the next step down the line is the power company was out there running some tests on, putting on a new crossarm. You leaving, going home?
Yeah, 'cause you're over.
I got something that's more important, Walt.
Okay. Oh, I love him. Have a good one, Johnson. Anyway, I hope you give me a good rating.
You're doing good, Walt,
gave
but
you-
I've been here.
But anyway, the power lines out in front of my building, the first one level is about 15,000 volts. The second level is 33,000 volts. The third one is 130,000 volts. Every time I start working with 220 volt, changing a plug or that, I have learned over time to put my one hand in my pocket and wear rubber shoes, because every time I get in there screwing around with it, I burn the tip off of my pliers. I'm not smart enough to put a meter on it. Check it out. These guys work on that high voltage lines when it's still live. And that, explosives are simple. That is just terrifying. But anyway, they were putting this post on, this crossarm, and doing this, and there's 110 in the shade, and sometimes there's not too much shade out here at China Lake. And they were out there with a hacksaw sun on it, and I waved to them, and they come sailing down. I had a couple of friends over there. They come sailing, and I handed them this little cutter. They went up with it, popped it, it cut it off, and they said, that's fantastic. Southern California Edison now has 189 of these tools. And they keep using them because they keep buying cartridges. And that makes me happy. We also designed and developed tools to cut underground cable. And this is what underground cable looks like. And Ridgecrest has a whole bunch of the underground cable. And then we have another tool that cuts what is known as ACSR, and it's aluminum conductor, steel reinforced. And what it is the they string these wires and cables all over the country with this aluminum conductor, steel reinforced wire, and the steel supports it. And it's guy wire in the center section. And guy wire is just tougher than heck to cut. I had these bolt cuts down at Micronics to cut locks off of the girls that forget their keys to their lockers, and I'd cut them off with it. When you try to cut guy wire with this thing, I can't even get it in it. What it does is it's hard. Oh, shit. I'm sorry, ma'am. I'm in trouble now. Anyway, it's extremely hard, and it's real tough, and I'm out of drink too. Sorry about that. And this little cutter just cuts it slicker than heck. It can cut up to 1/2-inch guy wire. In fact, for LADP, Los Angeles Department of Water and Power, I cut up 3/4-inch guy wire. And the guy wire is used there to support the cables. The other aspect on it is Southern California Edison came along and said, we need to spike underground cable. And when they have a cable that's down and not working, they need to verify before they touch it that it's not hot. You can put a meter on it, and if it's shut off, it's not going to tell you anything. So they go in and they have a hot stick, and they stand outside the vault, and they run this thing down through the vault and screw this screw into the cable. Well, they were doing that at 2 o'clock in the morning up at a place that came to a screeching halt, and they went into the wrong vault. They screwed it in, hit a live cable. That shock came out, hit the guy, and tore him in two. And then there's 2 guys standing alongside that burnt their faces real bad and burnt their ears off of them, and it cost them about 200 grand apiece for them. And as a result, they come along and outlawed the use of that spiking tool. So they said, can you develop this one? And so we have designed and developed the A6, A7, 8, and A9 tools there to save their lives. And that's technology that was designed and developed here at the Aerospace China Lake. So I'm glad to see it moving out. The center needs to have a major program installed to start marketing this technology to the outside world, because us guys out there in the outside world need it. Let me tell you about technology. I'm going to take 10 more minutes.
Oh, we have to get moving here. It's no close.
Oh, okay. They don't close until 7.
No.
Anyway,
Can we answer
questions.
questions?
Yep.
If anybody has any?
You never mentioned Lyndon Johnson or something.
Yes.
Oh!
He's very modest about that.
We on these safe arm devices that we developed for Tartar, Terrier, and Sparrow, they manufactured they manufactured a whole bunch in about a 3-year period of time. And the old devices were costing $1,200 to $1,600. And that new device was costing right around $100 a piece. We had saved $20 million in a 3-year period of time on those S&A devices, and there was 7 of us received the presidential citation. Now, the other 6 guys that were involved with me on the program that did 90% of the work, they've all died, and so I get to brag about it. Any other questions? We're out of here. Yes, ma'am.
You just talked about how you calculated the savings from $1,200 to $1,600. You saved about $20 million over 3
Yes.
years.
Uh-huh.
And then we had another figure in our poster that was
A billion.
Oh, no, that's on, over the last 25 years. I was going to get into that, but she told me I couldn't go any further. Over the last 25 years, it has saved over $1 billion, and our old buddy who wrote this and did most of the work on it come along and called me the $1 billion man, and I don't sort of agree with that aspect, but I take it. But yeah, you're right. It saved over $1 billion over a 20-year period of time.
Original cost times how many missiles then were
Yeah.
built using.
Yeah. And he went through the numbers, and he did a hell of a good job. And when he put this package together, and I started reading, I was dumbfounded with it. Now, when I had the negotiation with this lady here about the thing, and she said, "Well, Walt, you could have gone up to the thing and bought them for $30 a piece." And that's when I told her that $90 is an awful lot of money, and I can't afford that. So
We have
that's
something else for you as well.
okay. Yes, ma'am.
I have a big poster for you.
Yeah.
Of your poster, it's what we have the smaller ones of, and then a certificate to thank you very much.
Holy mackerel, this is scary.
Yeah.
Thank you, guys. And I appreciate it. Oh, I can see that now.
Yeah.
This is the one I was after. Look at that.